Welcome to AlgaeOmnios Prep Academy. The lesson for today is finding the absolute maximum and the absolute minimum using the first derivative test. The absolute maximum is the highest point, while the absolute minimum is the lowest point. Here are the steps to finding the absolute maximum or the absolute minimum. Step 1 is to find the derivative of f. Step 2 is to find the critical points. And the critical points are when the derivative of f is equal to 0 or undefined. Step 3 is to draw the number line for the derivative of f. Step 4 is to estimate the graph of f. Step 5 is to determine which possible values to check. Step 6 is to get the answer, which is the absolute max or min, by comparing values. And step 7 is to give the reasoning as to why your answer is the absolute maximum or the absolute minimum. Problem 1. Find the absolute maximum and absolute minimum of the function f of x equals x cubed minus 6x squared plus 12x minus 8 on the interval -2 to 4 inclusive. The first step is to find the first derivative of f and factor. The first derivative is equal to 3x squared minus 12x plus 12. We can simplify this by factoring the 3 out, and also by rewriting x squared minus 4x plus 4 as x minus 2 the whole squared. The second step is to find the critical points, which are where the derivative is equal to 0 and undefined. The derivative equals 0 when 3 times x minus 2 the whole square equals 0. By using simple algebra, we can find that x equals 2. The derivative is also undefined at no points. The third step is to find the derivative number line. We can draw the number line for f prime using the first derivative test. We can place bounds at -2 and 4 and a 0 at x equals 2. Since f prime of 0 is equal to 12 and f prime of 3 is equal to 3, and both of them are positive, we place positive signs on the number line. Now we can estimate the graph of f. Since the f prime number line is always positive on the interval -2 to 4, the graph of f will always be increasing. Please make sure to line up the graph of f with the respective corresponding points on the derivative number line. The fifth step is to determine which values to check. We only need to check f of -2 and f of 4 because they are the absolute minimum and maximum as seen on the estimate of the graph of f. The absolute minimum at x equals -2 is f of -2, which is -64, and the absolute maximum at x equals 4 is at f of 4, which is equal to 8. We don't need to check f of 2 because f of 2 is not the highest point or lowest point as we can see on the graph of f. The sixth step is to find the absolute maximum and the absolute minimum, which are our answers. The absolute minimum is the least value, f of -2 equals -64, because f of -2 is less than f of x for all x in the interval -2 to 4 inclusive. The absolute maximum is the greatest value, f of 4 equals 8, because f of 4 is greater than f of x for all x in the interval -2 to 4 inclusive. Problem number 2. Find the absolute minimum of the function f of x equals negative of x cubed minus 4x squared plus 4x on the interval -5 to 3 inclusive. First, we need to take the derivative of f. The derivative of f can be written as negative of 3x squared minus 8x plus 4. We can further simplify this derivative by writing it as negative of 3x minus 2 times x minus 2. The second step is to find the critical points. Again, the critical points are where the derivative of f is equal to 0 or undefined. The derivative is equal to 0 when 3x minus 2 is 0 at x equals 2/3, and when x minus 2 is equal to 0 at x equals 2. The derivative is never undefined. After finding the critical points, we need to find the derivative number line. We can start by marking the bounds at x equals -5 and x equals 3, and the zeros at x equals 2/3 and x equals 2. Using simple algebra, we can find that f prime of 0 is equal to -4, f prime of 1 is equal to 1, and f prime of 5/2 is equal to -11/4. Since f prime of 0 and f prime of 5/2 are both negative, the derivative of f is also negative over the interval -5 to 2/3 and the interval 2 to 3. Since f prime of 1 is positive, the derivative of f is also positive over the interval 2/3 to 2. The fourth step is to estimate the graph of f. We can use the derivative number line to help us get an idea of what the graph of f looks like. The graph of f will decrease over the interval -5 to 2/3 and the interval 2 to 3, because the derivative is negative. The graph of f increases over the interval 2/3 to 2, because the derivative is positive. The fifth step is to determine which values to check. There are possible absolute minimas at x equals 2/3 and x equals 3, since the graph is decreasing at its lowest points, at points where f has a minimum. We can calculate that f of 2/3 is equal to -32 over 27, and that f of 3 is equal to -3. It is important to note that f of 3, or -3, is less than f of 2/3, or -32 over 27. Now we're almost done. Our sixth step is to find the absolute minimum. We also have to remember to state our reasoning. The absolute minimum is the least value, f of 3, which is -3, because f of 3 is less than f of 2/3 for all x in the interval -5 to 3 inclusive.
Thank you for watching Algebra Prep Academy. Please like and subscribe.